And so we'll be discussing the use cases which are there for AI for autism. So there are a lot of use cases, both for because autism is a spectrum condition, so people are very different on the spectrum. And but there are some certain characteristics which are common to a lot of people. So we are going to see some common characteristics which may apply for a lot of people, and certain solutions with regards to those characteristics. So first use case we're going to see is going to be AI for early diagnosis of autism using MRI scans. So if you take early diagnosis is very, very important. The reason why early diagnosis is important is because the neural wiring of a child takes around 5 years to fully develop. And so if you can diagnose autism little early, then there is a lot of intervention techniques which can happen. And if a child can get early intervention techniques, then there's a higher probability that the child can be independent throughout their life. So that is why early detection of autism is very, very crucial. And so there are many techniques for early detection of autism. Some clinicians just see the face of the child and they detected behavior of the child. So there are different ways autism has been detected, but some of the deep learning techniques which are coming up are like early detection of autism using MRI scans. There's also a research from Stanford which says that autism can be detected as early as the mother's womb itself. So this is going to be using the first use case is early detection of autism using MRI scans. And one important thing is data set is very, very important for any of the data science use cases. Thankfully for us, we have a very good data set, which is the Abide pre-processing data set, which is brain imaging data exchange data set. And this data set is collected from people by neurologists across the globe. And this is a very exhaustive data set for autism. And it contains a collection of MRI scans. So the use cases like this, you take an MRI brain image, pre-processing, segmentation, and then feature extraction, and then you do classify whether the child has got autism or not. So this is how uh, pipeline looks like. And for the data set, we have the Abide. And for the algorithms, there's a lot of algorithms out there. And you can also see UNITAR, which is transformer-based architecture. Or you can use any simpler segmentation algorithms as well. So the second, third, and fourth use cases we are going to look at is about emotion detection in speech, emotion detection in text, and facial emotion detection. Because autistic people have trouble understanding emotions in multiple modalities. They have trouble understanding emotions in speech, text, and facial emotions. They don't understand the social language. They also have difficulty understanding the body language as well. So this is one of the main reasons why autistic person is finding it very, very difficult to fit into the corporate world. The reason is because the person is not able to understand emotions and the person cannot communicate clearly. And then, that leads to misunderstanding and that causes a lot of trauma for the autistic individual. And that is why it is very difficult for an autistic individual to fit into a traditional corporate life. So the emotion detection and having tools which can help them overcome these barriers will help them, be a part of the corporate life without much hassles. So the first modality which we're going to see today is going to be emotion detection in speech. So the emotion detection in speech, the emotion detection in speech The pipeline looks like that. You have the speech wave, then you have feature extraction, then speech recognition, and then the emotion recognition. Some of the architectures which has come up in the emotion detection space is MONET, which is a transfer learning framework for multi-corpus speech emotion recognition. And so there are many such architectures which are pre-trained models which are already available. The emotion detection and speech pipeline, text pipeline, for the data set, you have got Raptors data set, and there are a lot of corpus, speech corpus available. And so this is how the first modality looks like, how you can solve this emotion detection and speech problem in using AI. So the next use case is about emotion detection in text. So autistic people also have trouble understanding emotions in text. So if a manager is going to send an email containing a lot of indirect speech and sarcasm and humor, there's a higher probability the autistic person may not be able to understand the humor, indirect speech, and the sarcasm. And so it's very important to have a direct form of communication when you're dealing with autistic people. So to overcome this barrier, we can develop an AI-based tool which can detect emotions in text. And it's about input and labeled emotions, text pre-processing. So this is how a pipeline looks like. For the data set, we've got Go Emotions data set, which is coming from Google. And this contains 27 distinct emotions, and it's a range of conversation understanding, task. So the fourth use case, which we're going to see today, is about facial emotion recognition. So autistic people have trouble understanding emotions and face, and they cannot understand body language and social cues as well. So this is very interesting use case out there. So there was a lot of tools which in this similar format which had come earlier, like emotion detection using facial expressions using Google Glass, which was a product which was released few years back. It was shut down now. It's no longer in production, but it was still consumed by a lot of autistic people. And so for facial emotion recognition, this is going to be the pipeline. You have input image where you detect the face, and then you apply deep learning algorithms to do emotion labeling. So the data set which we have available for this is going to be FactNet, and this is going to be one of the models which has been doing really good for facial emotion expressions detection. So holistic AI can be used for teaching social and behavioral skills to autistic people, and so compared to humans teaching autistic people, robots are found to be much more efficient in teaching autistic people, because robots can say a certain thing for 300 times or 1,000 times and still not get tired of it. So robots are much more effective in teaching autistic skills about social and behavioral skills. There's a robot called Milo, which is out there in the market, which is around $5,000, which can teach autistic people, social and behavioral skills. But then we need more such tools in India as well, and which are somewhat, economical for the Indian economy. And so this is kind of the end of the use cases. So I think we're done with the session. If there is no question answers, any question answers, I can take it up.